All right, ladies and gentlemen, good evening. Looking today at 3.3 polynomials and synthetic division, looking at long division as well. So I think we can just go ahead and get started. We're going to begin with long division. And we're going to divide a couple things here as some examples. Most of today is going to be examples just because that's kind of how this lesson is run. And we're going to write our answers in two different ways. This is the first way. We're going to take the function and write it as the product of two functions plus some remainder function if there is one. Or we're going to write it as a fraction, f of x divided by d of x is equal to some answer plus some remainder out of a number or out of a function, out of the original division function. Okay, so what we're going to start with is numbers. So kind of jumping back to algebra, or not algebra, jumping back to like third grade here. So we remember that if I divide 237 by 3, I put 237 in the box in the house, and I divide by 3 outside. Okay, so you might remember what we do here. We're going to take 3 and we're going to look to see how many times does 3 go to 2. Well, it doesn't. So I move on to the next one. I say, okay, how many times does 3 go to 23? Well, 3 goes into 23 7 times. And we look at 7 times 3, which is 21. We draw a little bar here and we do some subtraction. 23 minus 21 is 2. Drop down the 7. And then we say, okay, how many times is 3 going to 27? Well, it nicely goes in there 9 times. And 9 times 3 is 27. Well, that's nice, which means there's no remainder. So if you remember, some of the times we used to write this remainder 0 or remainder 7, remainder 10, whatever the problem was. But we're going to write our answers in a couple different ways. We're actually going to write it in both the ways as mentioned above here. Even though we're not dealing with functions, we can do it numerics as well, with numbers as well. So we're going to say that 237, the original number, is equal to the product of 3 and 79 plus 0 remaining. Okay, so yeah, I know we don't normally write the 0, but we're going to do that for now. Okay, so let me get rid of some stuff here so I can have a little bit of room. All right. The other way to write this is as the fraction of 237 divided by 3 is equal to the 79 plus 0 out of the original 3. And I know, again, we don't usually write this, but if there was a remainder, we could write this as a remainder of 1 over 3, 2 over 3, whatever. All right, so this is how we do long division. You might remember this from elementary school. And hopefully you remember a little bit of long division for polynomials from last year. So here's our first example. Notice we're taking a cubic, this big long cubic here, and we're dividing by a linear factor. And just as before, the thing we're dividing by goes outside the house. And then we're dividing into goes inside the house. Like that. Okay, so the same idea holds here. We look to see, in this case, we only look at the first thing here. So we take this x and we say, what could I multiply by x to get 6x cubed? Well, I need to multiply by a 6 to get the 6, and then I need to multiply by x squared to get x cubed. And then I'm going to take this 6x squared and I'm going to distribute on top of both of these x and the minus 2. So I'm going to get 6x cubed, which is good because that's what I want to cancel that out, minus 12x squared. And again, just as before, I'm going to do a simple subtraction. Well, my 6x cubes go away. And negative 19x squared minus 12x squared. minus a negative 12x squared is actually going to be a negative 7x squared, negative 7, plus 16x minus 4. And then I'm just going to continue this process. X times a negative 7x gets me this negative 7x squared. And then negative 7x times negative 2 is plus 14x. And you notice this process just kind of continues. It just keeps going. And those go away. I'm left with 16 minus 14, which is 2x minus 4. And then I go, okay, x times a 2 will get me a 2x. So I need to do a plus 2. And when I distribute, I get 2x minus 4. And lo and behold, I get 0, which means there's no remainder. All right, so what I need to do is I need to write this as a summary statement as an answer here. And I'm going to erase that. Actually, I'm going to undo that because I need to know what the answer was because I don't remember what the answer is off the top of my head. So I'm going to erase a whole bunch of other stuff. And eventually, when this gets all gone here, I'm going to write my summary statements. Okay. So what I can say is, first of all, I can say, okay, the first summary statement would be 6x cubed minus 19x squared plus 16x minus 4 is equal to the product of two factors. Well, it's equal to the product of x minus 2 and that quadratic 6x squared minus 7x plus 2 plus no remainder. So I don't have to write the remainder out here. That's way number one. Way number two would be to write it as a fraction. 6x cubed minus 19x squared plus 16x minus 4 over the original division, so that's the x minus 2, is equal to, well, it's equal to this thing above the house up here, if you want to call it the house, that 6x squared. So 6x squared minus 7x plus 2. And again, there's no remainder. But we would write it, if there was a remainder, we'd write it as a plus 0 out of x minus 2, whatever that original thing in the denominator there was. All right, so you're going to have to write the answers in one of these two ways. For the most part, they're going to call, I don't remember if the book calls them summary statements or not, but I know I call them summary statements. Okay, so if I get rid of this, let's look at a second example. So here we're going to take a quartic and we're going to divide by a quadratic. And so the same process holds. We're going to say, okay, x squared minus 2x plus 3. And we're going to go in, divide into this quartic. Now there's something you need to be very careful about here. And that's the fact that there is no cubic term on this quartic. Oops. And since there's no cubic term, you need to put one in. And by putting one in, I mean putting in a 0x cubed, right? It doesn't change the problem, but it's like a placeholder. To make sure we line everything up correctly. So the process here, x to the second times x to the second will get me x to the fourth. So x to the second times x to the second, x to the fourth, then distribute, I get a minus 2x cubed and a plus 3x squared. I subtract, this goes away, this ends up going away, and I'm left with a negative 2x cubed plus 0x squared. Keep the 0 there because I kind of need it again as a placeholder. Oh, something else I didn't pay attention to is I don't have a linear x. Okay, so luckily I can still add this in here. I can add a plus 0x plus 1. Luckily I didn't get it out of the way there, or I didn't use that piece already. All right, so continue the process. X squared times a negative 2x gets me negative 2x cubed minus, or actually plus 4x squared minus 6x and, oh, that's it actually in this case, Continue the process. Subtract. That goes away. 0 minus 4. Make sure you get a negative 4x squared here. And then 0 minus negative 6. So that actually ends up being a plus 6x. And then here I get a plus 1. And I have to go one more time because I can multiply by something by x squared to get negative 4x squared, and that being a negative 4. So I multiply there, I get negative 4x squared plus 8x minus 12. And notice here I'm going to get a remainder. So it'll help us out a little bit looking what a remainder is going to look like. So 6 minus 8 is negative 2x. 1 minus negative 12 is plus 13. Now you notice I can't multiply anything by x to get, or x squared to get negative 2x. So I'm as far as I can get. So I have a remainder of negative 2x plus 13. We're going to use that in a minute to write our summary statements. So let's erase a little bit of stuff here and see if we can't get a summary statement going. All right, this is kind of frustrating here, but whatever. You can bear with me. All right. So our summary statement would be, okay, so I know that x to the fourth plus 3x squared plus 1 is equal to the product of two things. It's equal to the product of x squared minus 2x plus 3 and x squared minus 2x minus 4, and has a remainder of, actually let's write this as minus 2x plus 13. We can write it like that. We could also write it as the fraction version, x to the fourth plus 3x squared plus 1 over x squared minus 2x plus 3. This is equal to whatever the thing was on the top of the box up there. This was x squared minus 2x minus 4 plus the remainder over the original denominator, x squared minus 2x plus 3. So you notice there's our two summary statements. When you go to write anything, you're going to write one or the other, not both, usually. Unless I ask you to write both, you don't have to write both. All right. Let's move to synthetic division. This is something people like a little bit better just because it's a little bit easier. However, this is just a simplified version of long division. However, this can only be used with linear factors. Please pay attention to that because you cannot, that last problem we just did, you cannot do with synthetic division because it's dividing by a quadratic. If you divided by a linear factor, you can use synthetic division. So what I want to do is I want to divide x squared plus 3x plus 5 by x plus 1. And what I do here is I plug in the 0. The 0 of this, whatever makes this thing 0, the x plus 1, goes inside what I call the box. So negative 1 makes this thing 0, so I'm going to plug in negative 1. And then I look at all of the coefficients of this quadratic. So the coefficients are 1, 3, and 5. And notice this is all the more room you need to do synthetic, and this is why people like this even better. Okay, so what I'm going to do is I'm going to drop this 1, and I'm going to multiply negative 1 times this 1 to get negative 1. And then here's where it's different. I'm going to add 3 plus negative 1, and I'm going to get 2. And then I can do this again. Negative 1 times 2 is negative 2. And 5 plus negative 2 is 3. And this last number here, whatever goes inside this last piece, that is your remainder. And then what we want to do here is we want to look at this. This number right here, just next to the box, this is my constant. The number to the left of that, that's linear. If you went any farther, the next number would be quadratic. The next number would be cubic, which means this, when I do this division, I can say x squared plus 3x plus 5 divided by x plus 1 is equal to x, because this is the linear term, so I get 1x plus 2 as my constant term, plus a remainder of 3 out of x plus 1. And notice how much faster that was. Okay, I have another example here that we can look at. All right, so same kind of idea. I want the 0 of my factor, which in this case is a -3. That goes inside my box. Again, for this particular quartic, notice I'm missing a cubic term, so I need to plug in 0 for my coefficient of the cubic. So my coefficients are 1, -10, -2, sorry, and then I forgot it. Undo. All right, 0 for my cubic, -10, -2, 4. See how easy it is to forget? Okay, it's very easy to forget. All right, so same process. Drop the 1. -3 times 1 is -3. Add, I get -3. -3 times -3 is 9. Add, I get -1. -3 times -1 is 3. Lost my train of thought there. Add, this is 1. -3 times 1 is -3. Add, this is 1. Notice that means I get a remainder. If I write my answer here, I'm going to say this is x to the 4th minus 10x squared minus 2x plus 4 divided by x plus 3 is equal to, so here's where you have to pay attention. This is a constant term. This is a linear term. This is the quadratic term, and this is the cubic term. So that means I get 1x to the 3rd minus 3x squared minus x plus 1 plus the remainder out of the original division. And there would be our answer here. I may even have one more example like this, because this is an important concept to get. Oops. Oh, I don't. Oh, my goodness. All right, so I have the remainder theorem. The remainder theorem kind of goes along with synthetic division. It's kind of nice for us. It says if we divide a polynomial by a linear factor, so notice we have this x minus k. This is a linear factor. The remainder is f of k. That means if I plug this k value into the function, that would be the remainder. And that actually helps us really simply find out what f of k is. Essentially, we can use synthetic division to figure out what f of k is. So here's the question. If I wanted to find f of -3, yeah, we could plug in -3, but that people mess up negative signs all the time. So what I want to do is I just want to do synthetic division. If I plug in -3 in my synthetic division, and I look at my coefficients, notice I'm missing the quadratic, so I got to plug in the 0. And then most of you are going to get really quick at synthetic division. If you're not already, drop the 2, make this a -6. Add, make this an 18. Add, makes that a 14. -3 times 14 is -42. Makes this a -39, which means f of -3 is -39. And you could actually figure that out for yourself by plugging in -3 into our function. But notice how quick and simple this was. No calculator needed. Maybe for some of you, what was 14 times 4 or 14 times 3, you might have needed that. And we can also do it to see if 2 is a 0 of the function. It's a 0 of the function if the remainder is 0, or if f of 2 is 0. And I'm just going to do this really quick using synthetic division. So I'm not missing any terms, so I get all these numbers here. No zeros. And I'm just going to do a quick synthetic division, just kind of follow along here. Drop the 2, that's a 4. Add, multiply, that's a 9, makes that an 18. Look at there, that makes it a 0. That means f of 2 is a 0, so the answer is yes. And that actually ends up being an x-intercept, right? 2 is an x-intercept of this particular function. All right, so that finishes off for the day. You have the assignment sheet already. This will, the due to me section, you guys I hope are getting a little bit familiar to this now, is the 7 problems. Those are due to me by the end of class tomorrow. I hope the video made sense, and come to me with any questions tomorrow. All right, see you guys.